Here we go. Let's keep going. For some reason, there we go. All right, let's see. Oh, now we're going to do that sine, cosine, tangent thing with this. But now we have two angles. Remember, the other one just had the same angle for both of the angles, 45 and 45. This one, you have a 30 and a 60. So we're going to do the sine, cosine, and tangent of 30, and then we're going to do the sine, cosine, tangent of what?
60.
60. Okay, good. So the sine of 30, we're going to do the cosine of 30, and we're doing the tangent of 30. And we're going to find the same relationships. We're just using our trig relationships. So the sine of 30 is opposite over hypotenuse. So let's just put it in here. So it's what? X over 2x. Okay, let's see what happens here. That cancels with that. You got a 1 on the top, so it's just 1/2. Again, that's another number that's going to show up. After a while, you're going to be expected, like I told the other class, I said, you're walking down the hallway, I can tap you on the shoulder, and I'm going to say, Stephen, tell me what the sine of 30 is, and you need to tell me what the sine of 30 is. Okay, it needs to be memorized. But we're gonna show another way. We're actually going to relate these to circles in another chapter, in the next chapter. It's called the unit circle, and you'll see how it all works together. But this is, again, just an introductory kind of thing with this, okay? So let's do the cosine of 30. Let's speed this up a little bit. We only have a few minutes left in class. So the cosine of 30 is adjacent over hypotenuse. So it's the square root of 3x over 2x. The x's cancel, and you're just left with the square root of 3 over 2. Again, that's a number that should be easily recognizable and needs to be memorized. Okay, that's an important number in this whole scheme of things. Let's do the tangent of 30. The tangent of 30 is opposite over adjacent. So it's x over square root of 3x. Right, this is where we kind of came up with this on the 45, didn't we? The x's cancel. There's a 1 on the top. What do? We can do this in our head, can't we? Square root of 3 over 3. Right. At this point, you should be able to get rid of that just in your head without writing it out. That's another number that you need to have memorized. Now, remember yesterday we talked about this? We said the sine of 30 would be the same thing as the cosine of 60. That's right, of its complement, right, which is 60. And the cosine of 30 would be the same thing as the sine of 60. The tangent of 30, if it's 1 over the square root of 3, should be, the tangent of 60 should be what? The inverse of that, correct, square root of 3 over 1. Let's see if that really works using our relationships here. We're almost done. 30, 30, and tangent of 30. I don't know why I put a big space there. Sine of 30, let's do this. It's opposite over hypotenuse. So it's x over 2x. Check it out. That's a half, isn't it? Just like, what did I do that for?
I don't know.
Somebody stop me. Watch, Control Z. Watch this. Boom, 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 boom.
It's so special.
Look at that. Okay, let's try this again.
Sine of 60.
I guess I should edit that, but I'm not going to. I thought you guys would stop me.
You're human.
I'm very human.
Mistakes.
I make a lot of mistakes. All right, let's try this again. Sine of 60. Let's come up here to 60. I'm running out of time. Sine of 60 is opposite over hypotenuse. So it's the square root of 3x over 2x. The x's cancel, and there you go. Isn't that the same as the cosine of 30? Yes. Sure is. Check it out. We said it was, right? And we should have recognized that before we even did this. Cosine of 60 is adjacent over hypotenuse. So it's x over 2x. And that cancels with that, and it's 1/2. 60 should be the inverse of this, 1 over square root of 3, shouldn't it? Let's see if it is. It's the what? Opposite over the adjacent. So it's the square root of 3x over the adjacent, which is x. Sure enough, just like we thought it would, and it does. Again, these are things that should be memorized. All right, how much time? I got like 2 minutes left. Let me go over one little concept. This is something, again, we did in geometry last year. Do you remember talking about angle of elevation, angle of depression?
Yeah, about remember.
All right. Let's a very common type of problem is like somebody's on a cliff. Pretend this is the cliff right here, okay? And somebody's standing on the cliff. There's my great artwork. And yeah, there's shadows and trees and all that kind of stuff. I'm just going to use the cliff example, okay? And I don't know, you're looking down at the ocean and here's a nice boat. There's my cool sailboat. All right. So they're looking down like this. And I'm not going to give you an exact example just because of time. But they're going to talk about the angle of elevation and the angle of depression. All right. So actually, I was going to do this in a different color, but we'll just do that. That's the horizontal. From where they're standing, that would be the horizontal. The angle of depression, now listen, this is important. The angle of depression is always from the horizontal to, oops, I forgot to go back to a regular pen. From the horizontal to that line of sight, or to that angle right there. That's the angle of depression, so we'll call it theta. All right? But you look at that and you say, well, that's not even in the triangle. But that angle is in the triangle. Where is it? It's down there by the boat, right? And they're not complementary. They're alternate interior angles. Okay, do you remember that from geometry? Parallel lines cut by transversal, the alternate interior angles are equal to each other. So that's why this is theta and this is theta right here. And they'll tell you stuff. They'll tell you, okay, the cliff is, I don't know, 50 feet high. The boat is, I don't know, 300 feet away or something like that. And then find what the angle of depression is. It's not this. This is what a lot of people find right here. They think this is the angle of depression. It's not. It's from the horizontal down to that side right there. Everybody get that? All right, so you're really finding this angle. So what trig function would you use? Opposite over adjacent, tangent, and from there you could do that. All right? So that's the kind of stuff you're going to see as far as the word problems are concerned. Let me give you the assignment, and I'll write it on here so that if people are absent, or if you're absent, you know, you can look at this YouTube thing, and if you don't want to watch the whole lesson, at least you can, you can skip to the end and see what it is. So it's section 13.1. Now it seems like a few problems, but a lot of the beginning problems are pretty easy and quick to do. So it's 8.13 and 8.14, and we're doing 13 to 45. Yeah, doing them all. Okay, so there it is right there. Everybody good? All right, everybody say goodbye.
Goodbye.